Okay, so by now we know how to use similarity. We know the similar means two shapes that are this they look the same. They look the same shape, but they could be different sizes. Now we're gonna use similarity since we know how to deal with similarity. We're gonna use similarity to solve real life scenarios. So let's take a look at number 21 and 22. Round each question and round your answer to the nearest tenth. Okay, so that means my answers will be decimals. Now, tenth, okay. Tenth, for us to remember how many decimals that is, the last two letters, TH, that tells me it's a decimal. Now, the first letters, it sounds like 10. Now, when I think of the number 10, I ask myself, how many zeros are there in the number 10? So, tenth means to the one decimal place. Oh, okay. So that's easy. If I had something like hundredths with a th at the end, hundredth, I'm talking about two decimal places. Okay, so make sure your answer is rounded to the nearest tenth. Like I said, do expect decimals. So we're looking at number 21. There's a flagpole. I'm not the great artist, but flagpoles are usually going up. So I'm going to represent this. Let me do this in red. Let's say there's a flagpole. Something's going up and it has a shadow. So it casts a 19.9 shadow. So there's a flagpole that has a shadow. So the shadow is usually on the floor, right? And it's usually like this. It's not measured to scale. I'm just creating a pole and a shadow. Now I see some numbers, right? When I read the first sentence, a flagpole that is 19.9 feet tall casts a shadow that is 89.6 feet long. Okay, so I have a measurement for the pole and a measurement for the shadow. Okay, so the flagpole that is 19.9 feet tall. Okay, so I'm going to say the pole is 19.9 and the shadow is 89.6. The shadow is 89.6. Now, just for us to use it how we've been looking at the figures that we've been looking at, again, this is not measured to scale. So don't think they look almost the same size, but again, it's not measured to scale. It's just for us to represent it. Let me close this figure because we've been working with triangles. So let me work that figure so it looks like a triangle. But I know is the height of the pole and I know it represents the shadow. Now it says find the height of a lawn ornament. So that casts a shadow of a cast a 7.2 feet shadow. So there's an ornament. There's something going up and it has a shadow. So something going on the floor, something like this. Again, it's not measured to scale. I'm just representing something. I want to find the height of the lawn ornament. So I have no idea what's the height of this. And I know in mathematics, when we don't know the value of something, we replace it with the letter. So I'm going to say the height of this thing is X. But the shadow, right, it casts a shadow of 7.2 feet. So this is 7.2. Now notice how I ignore the measurement on all of them. They were all feet and I ignore them because they're all feet. So I'm dealing with feet. Now just make sure our answer, we know it's in feet, but I'm just going to ignore it. Right now, at this point, I just want to make sure that you know how to do the operation. You know how to solve for the value, but we know this is in feet, okay? And again, like I did on the red triangle, let me close this side so it looks like a triangle. And I know for proportions, I make two fractions. So let me change this to black. From the blue triangle, I have the measurements X and 7.2. Now, X is the height of what I'm solving for, in this case, a lawn ornament. From the red triangle, the height is 19.9. So I'm just going to put 19.9 with X, and 7.2 goes with 89.6. And I'm going to cross multiply it. I know my answer is what I have to round to the nearest tenth, my answer, but not my work. So let me cross multiply. 89.6 times x is just 89.6x. That's the easy part. On the other way, when I go diagonal, I'm just going to multiply 7.2 times 19.9, and that gives me 143.28. I'm not rounding just yet. My answer is what gets rounded, not my work. So notice how I wrote 2 decimal places. I'm writing everything that I get. I'm not rounding just yet. Okay, now to get the x by itself, let me divide both sides by the number in front of x. So let me divide by 89.6. That way I get x by itself. And then I'm going to go 143.28 divided by 89.6. According to my calculator, I get 1.599107,143. Okay, so I get like a bunch of numbers. Okay. In reality, I only need 2 numbers for now. Okay, I know my answer because I'm looking at my answer. I'm gonna write 2 decimal places. I'm gonna erase that. Okay, so I'm just looking at 2 decimal places. Even though it said rounded to 1 decimal place, I'd write, for the moment, I write 2 decimal places. And the reason why I write 2 decimal places because I'm gonna look at the second decimal number. If in this case, this 9. If this 9 is big, it's a big number, it's gonna push the 5 up. So it's instead of being 1.5, it's gonna be 1.6. Now, if the second decimal number is too small, it's not going to be able to do anything to the 5. So it's going to be 1.5. Now, what makes a big number or a small number? A number that is 5 or more is considered big. A number that is 4 or less is considered small. And I said, if the number is big, which in this our case, because 5 or more is going to push the 5 up. So my answer will be 1.6. The 9 is big enough, so it pushes the 5 over. Now, if the second decimal place was too small, I would just call it 1.5. That's why I look at a second decimal place. Okay. Let's do another example like this. So there's a red triangle, a red figure. So I have a 2.6 feet tall globe standing next to an adult elephant, cast a 4.2 feet shadow. Okay, so something about a height and something about a shadow. Again, it's not measured to scale. I'm just doing a representation. So 2.6 feet tall. So the height is 2.6 feet and the shadow is 4.2 feet. Again, I'm ignoring the feet right now, but we know we're doing everything in this case. In this case, feet. It might say inches, centimeters, whatever it says, but we know our answer is in relation to feet. Again, I'm just focused on the numbers. I want to make sure you know how to work this. And I'm just going to close this figure so it looks like a triangle because I know how to work with triangles. Then if I can read a little bit more, it says, if the adult elephant, let me just represent there's going to be an elephant standing, and I'm pretty sure there's going to be some shadow. So if the adult elephant casts a shadow that is 12.8 feet, okay, so I know the shadow is 12.8. So cast a shadow that is 12.8 feet long, then how tall is it? Okay, so I don't know the height of the elephant in this case, so let me just call it X. And again, I'm going to close this figure because I know how to work with triangles. So based on the blue triangle, I'm going to write X and 12.8. I'm going to write 2 fractions. All right, X and 12.8. These values, I got it from the blue triangle. Now, X goes with 2.6, right? Height goes with height. So X is going to go with 2.6 and 12.8 is going to go with 4.2. And I'm just going to cross multiply. 4.2 times X is just going to be 4.2X. Right, that's this way. Now 12.8 times 2.6, that's this way. That is equal to 33.28. Now to get the x by itself, let me divide both of these sides by 4.2. I always divide by the number in front of x. So let me divide by 4.2. I'm only going to write 2 decimal places. So according to my calculator, this says 7.92. All right, I was asked to round it to 1 decimal place, but I'm going to write 2 for right now. I take a look at the second decimal place. If it is big, it pushes the previous number up. If it is small, I'm just going to ignore it. 5 or more is big, 4 or less is small. Now this 2 is small, so I'm just going to ignore it. So it goes away. I'm going to ignore it. My answer is 7.9. Now, if my second decimal place was big enough, it will push the 9 over. Do me a favor and don't call it 7.10. If my second decimal number would have been big enough to push the previous number up, 7.9, do not call it 7.10, right? Because 0.10 is the same thing as 0.1. So instead of rounding it up, you brought it way, way down. Instead, so let me just look an example. Let's say I had something like 7.96. This 6 pushes the 9 over. But again, I'm not going to call it 7.10 because the 9 is at the limit. The 9 ends up pushing the 7. So my answer would have been 8.0 or just 8, right? The 0.0 in this case can be ignored. But like I said, do not call it 7.10. If it goes up, do not call it 7.10. Okay, the 9 will push the 7, so it becomes 8.0. Okay, so that was not bad. Looking at this, not bad. Make sure you guys know how to round this properly. Let's take a look at number 23. We're going to be looking at solving for x when I have parallel sides. So those arrows that I see are just for me to see that are parallel sides. Okay. Now, one of my sides, when I mean sides, let me highlight. One side is in red, and let me highlight one side is in blue. All right, from the two sides, the red or the blue, there is one side that is all numerical. So I'm focused on the side that is all numerical. There's only two values. In this case, the 6 and the 8. I'm paying attention to the side that is only numbers. Okay, all numerical. Even though there's two values, 6 and 8, I should be able to have three values. Again, there's only two values, but I should be able to have three values. I'm gonna say from here to here, right? If I go this whole segment, it happens to be 14. Notice how I added those two segments, 8 and 6. I added those to make 14 because I'm looking at the whole segment. Now, because I had the two small pieces given, I added those to come out with 14. But let's say, let me erase one of these. Let's say I was given this, 14 and 6. I was not given the other side. In this case, for me to find the other small side, I would subtract 14 minus 6, which in this case happens to be 8. Okay, so we have that. Okay, so the one side that is only numbers, so the one side that is all numerical, you should be able to have three values. From those three values, you're only going to use two, but you're not quite sure which two are you going to use. Now, from the side that has the x, let me write this in blue. I'm gonna write 2x minus 2 and 21. If you notice, I'm using my two values, 2x minus 2 and 21. I'm gonna write two fractions. It doesn't matter which one you write first, okay? As long as they're separated. Now, 2x minus 2 is this small side right here only. So 2x minus 2 goes with this small side. So that goes with 8. 21, if you notice, it's the whole thing. That's this big number. So 21 goes with 14. Remember how I said on the one side that is all numerical, you needed to have three numbers, right? Two small values and a big value. So two small numbers and a big number. From those three values, you were going to use two. You just didn't know which two. Now you know. Okay, so 2x minus 2 over 8 is equal to 21 over 14. And the same way I've been working with, let me cross multiply. Let me cross multiply this way because of the minus. I'm going to have to go 14 times 2x and then 14 times 2 with the minus in between. So that's going to give me 28x, right? Because I went 14 times 2x. So 28x minus 14 times 2 is equal to, now 21 times 8, I know it's 168. So 21 times 8, we're going to call this 168. Again, we're solving for x, so let me separate my sides through the equal side. I want the 28x by itself, so I want to get rid of this minus 28, and I'm just not going to just cancel it. Instead, I'm going to move it to the other side. Don't forget to switch the signs. So instead of minus 28, let me write this as plus 28. So that's going to give me that 28x is equal to 196. Right? 168 plus 28, that's how I got 196. Now to get x by itself, let me divide both of these sides by 28. Now 196 divided by 28 happens to be 7. Okay, my instructions were solve for x equals 7. Now let's take a look at number 24. There is one side that is all numerical. So I'm not looking at the side that has x. I'm looking at the side that is all numerical. And I'm going to say this little side right here is 8. In this case, I was not given the two small numbers. So I was not going to go 6 plus 14. Instead, I was given a small number and a big number, like the big side. So I was going to subtract those, 14 minus 6. And that's how I solved the other side was 8. Okay, so now on the side that has the x, I'm going to use, so I'm looking at this side. I'm going to say 4x and 21. I'm going to write two fractions. I'm going to write 4x and 21. Okay. Now 4x is this, let me do this with blue. 4x is this side, so that goes with this value. So 4x goes with 8. 21 is the whole thing. So that goes with 14. Okay, I think we can cross multiply. I'm going to use red so we can easily stand out. Now I'm going to cross multiply. So I'm just going to go 14 times 4x. That's going to give me 56x. And then 21 times 8 is going to give me 168. And then when I divide by 56, let me divide by the number in front of the letter. So 56 in this case, 168 divided by 56 gives me 3. X is equal to 3. Okay, so that's the case when my triangles or my figures here have parallel sides. And I know they're parallel because the arrows indicate they're parallel. But now we're going to move into something that we call the angle bisector. Okay, so one of my angles of the triangle is cut in half. Angle bisector. So, okay, now this thing, I must know the four sides, the four small sides. So 2 sides per triangle. Number 25, I'm given what I need. Number 26, I'm going to have to work something out. Like I said, I need 2 measurements per triangle. Okay, like I said, number 26, I will have to work something out. For right now, number 25, I'm just going to write 10 over x. This is going to be pretty nice to write. 10 over x. You notice I went 10 over x. Now 10 is going to correspond to 25 and x is going to correspond with 20. So 10 over x is going to equal to 25 over 20. And I will be able to solve for x. Now let me cross multiply it, I guess. Let me use red so it stands out. 25 times x is 25x. 20 times 10 is equal to 200. Now I'm going to divide by the number in front of x. So in this case, let me divide by 25. And I'm going to get that x is equal to 8. Okay, so it was nice when I had all four sides. And then I said for number 26, I'm going to work something out. First of all, let me see these two values, x plus 3 and 12. X plus 3 is the whole side, and 12 is just a little side. So for me to find the remaining side, I'm going to go 5x plus 3, which is the big side, minus, and then let me put the small side inside parentheses. I put the small side inside parentheses just in case there's a plus or minus in it, okay? So 5x plus 3 minus 12. So matter of fact, let me write it here at the side because I'm going to work something out even more. So 5x plus 3, which is the big side, minus, and again, I put the small side inside parentheses. Just in case there's a plus or minus when I distribute, the sign is going to distribute properly. So I can simplify this even more. That's 5x plus 3. When I distribute the negative, that gives me negative 12 or minus 12. If there's a plus or minus in between, you got to distribute the negative to all the terms inside the parentheses. I can simplify this even more. I can call this 5x minus 9, right? Positive 3 minus 12 is a negative 9. So I'm going to say this small side, right here it is, 5x minus 9. Again, you need two small sides per triangle. This is what we're going to call the angle bisector formula, angle bisector rule. And then I'm ready to make my proportions. From the first triangle, the triangle that we see on the left, I'm going to use the measurement 5x minus 9 and 12. I mean 28. 5x minus 9 goes with 12 and 28 goes with 16. If you don't want to deal with big numbers, simplify your fractions. Right? 28 and 16, you can divide each by 4. Also, the numbers at the bottom, 12 and 16, you can also divide those by 4. You can always simplify. I'm not going to simplify because I'm going to use a calculator. You can use a calculator as well. So I'm not going to simplify, but again, if you don't want to deal with big numbers, simplify. All right, so let me multiply it this way. Let me cross multiply it. Because of the minus, I'm going to go 16 times 5, or in this case, 16 times 5x. And I'm also going to go 16 times 9. Okay, so I know 16 times 5x, that's going to give me 80x. Right, 16 times 5 is 80. Respect the minus in between them. 16 times 9, I know it's 144. And this is going to equal to 28 times 12. I know 28 times 12 is 336. Let me separate my sides with the equal sign. I want that term that has the x by itself. So this minus 144. I want to move it to the other side. Let me move it over as a plus. Got to switch the side. Plus 144. So that's going to give me that 80x is equal to 480. Right? 336 plus 144 is 480. Now to get x by itself, let me divide both sides by 80. because that gives me just 1x. 480 divided by 80 happens to be 6. So x is equal to 6. Make sure you can tell the difference between the parallel lines, the parallel similarity among parallel lines, and then similarity among angle bisector. And then we're even going to move into this new rule right here. This actually is called similar right triangles. Interesting part is that each figure has 3 triangles and they are all similar. Okay, so this figure have 3 triangles. Now, when I look at a triangle, let me explain something really quick. When I look at a right triangle, if I stand it up like this, it's going to have a small side, a medium side, and a large side. We know that the hypotenuse, the side away from the 90 degrees, the one farthest away from the 90 degrees. Remember how in mathematics, farthest away we call opposite. Okay, so the side that is opposite of the 90 degrees, we call it hypotenuse. But we know the hypotenuse is the large side. Again, these triangles have a small side, a medium side, and a large side. There are 3 triangles. There are 3 triangles in here, and they are similar. I can say this angle right here is 90. The reason why I know it's 90, because the other's 90 and combined have to add up to 180. Remember how in the first semester you guys learned angles of a line, right? The angle of a line is 180. We talk about that. So that's why I know that's 180. Now, there's 3 triangles. One of them, let me focus on the first one. I'm gonna highlight it in red. It has these 3 sides. And something about the 164. I can find out that this side right here is 36. Because I went the big side with the whole side minus 64. So it gave me that side right there is 36. Okay. Now there's a red triangle. There's a blue triangle. Let me highlight it in blue. The blue triangle, I can only tell that one of the sides is 64. I don't know the measurement of the other 2 sides. And then in black, let me highlight. There's a black triangle. And for that one, you can see there's a 90 degrees right here. For the blue, let me highlight the 90 degrees is right there. Okay, so now you can see a red triangle, a blue triangle, and a black triangle. Like I said, there are 3 triangles, but this rule, the nice thing of this rule is that these triangles are similar. So given some measurements of some triangles, I can find the measurements of the other triangles. Now, what I'm going to use, I'm going to use only 2 of those 3 triangles. So there's 3, a red one, a blue one, and a black one. From those 3 triangles, I'm only going to use 2 of them. And I'm going to use the 2 triangles where I know 2 measurements of each. It is okay if one of the measurement is x, right? So as long as I know 2 measurements of each triangle, those are the triangles I'm going to use. Let me use my red triangle because I can see that one side is 36 and I see another side that is x. Okay, so I know 2 values of that one triangle. And again, it is okay that I use x. So let me use my red triangle here. Now I have to identify the 36 and the x, whether they're the small side, the medium side, the large side. I know the one side away from the hypotenuse is always the large side is always the one side away from the 90 degrees. So I know this is the large side. From the other 2, I can compare them and I can tell this is smaller. So that means this is the medium side. So I can see which one's the small, medium, and large. Like I said, I need to know the small, medium, and large. And then remember how I have this black triangle here on the top? And I said I'm going to use that for me to use, I'm going to use that because that's how I'm going to write my triangles the same way. So that means for my red triangle, the small side I know is 36. I don't know anything about the medium, but I know the large side is X. So I'm using the same format. You see where the small goes, where the medium goes, and the large side. Now the blue triangle, I only know one side is 64. But remember how I said I'm going to use the two triangles where I know two values. I cannot use the blue triangle. Instead, I'm going to use the black triangle. I see my 90 degrees, so I know this is the large side. Remember, the large side is the one side away from the 90 degrees, the one side opposite of the 90 degrees. We usually call it hypotenuse, but that is still the large side. On the other side, I'm going to say the X is the small side, and this other side is my medium side. All right, so I want to list them as small, medium, and large. All right, the small side is X, so the X goes right here. The medium side, I have no idea what that is, but the large side is 100, so this is going to go right here. Okay. Using proportions, using similarity, I'm going to be able to solve for X. For us to be able to tell the difference of my work, let me use blue. Because I use the red and the black triangle, I'm going to use blue. Based on the red triangle, I'm going to use the values 36 and X. And then I know 36 goes with X on the black triangle, and X goes with 100. So, matter of fact, let me write how I did this. From the red triangle, I got my 36 and my X. From my black triangle, I got X and 100. Let me use the colors from the triangle that I got. Okay, so that's where I got these values from. I'm just going to cross multiply. So now I'm going to use blue. Okay. X times X. Do not call it 2X. That's if I'm adding. X times X is not 2X. Instead, X times X, we're going to call this X squared. And now 36 times 100 is going to give me 3,600 or 3,600, however you want to call it. So I'm thinking opposite operations. I know adding and subtracting cancel each other. Multiply and divide cancel each other. Exponents, because I have x to the second power, exponent is going to be canceled out with the radical. Some people call it square roots. Okay, so let me get the square root, because the radical, the exponent, we're going to deal with radicals pretty soon. But the radical or square root in this case, they cancel each other out. So that's how I'm going to get the x by itself. Now, using a calculator if you need to, the square root of 3,600 happens to be 60. Again, exponents get canceled out with roots or radicals. Okay, in this case, the exponent was 2, so we use square root. If the exponent was 3, I will do the cube root. Okay, so exponents, now we just learned, exponents get canceled with radicals. If it's the exponent is 2, we get canceled with the square root. Okay, that was not that bad. Let's take a look at number 28. What I'm going to use, I'm going to draw my black triangle here because I'm going to use this as a model. There's my 90-degree triangle. The small is going to go here, the medium is going to go here, and the large is going to go there. I'm going to use that. And again, there's 3 triangles here. There's a red triangle, and I know this is 90 degrees. There's a red triangle there. There's a blue triangle. Let me highlight my blue triangle. Let me highlight that this is my 90 degree from the blue triangle. And there is a black triangle. And let me highlight that there's my 90 degrees for the black triangle. Interesting though, is that this whole side of the black triangle, this is 36 plus x. That is this whole side. Notice how 36 and x combined is 36 plus x. Okay. So to begin with, I'm going to use the red triangle. Reason why I chose a red triangle is because I know two sides of that triangle. Now I need to identify the small, medium, and large. I know the large side is the one side farthest away from the 90 degrees. So I'm going to call this the large side. And I'm going to say that 36 is my small side and 48 is my medium side. Right? 36 is smaller than 48. Okay, so I'm using again the black triangle on the top to know where the small, medium, and large go. So for the 36 is gonna go here because 36 is my small side. 48 is my medium side, so 48 goes here. And then for my large side, I have no idea, so I'll leave it blank. Another triangle I'm going to use in this case is the blue triangle because I know two measurements of my blue triangle. It is fine for one of my measurements to be x. I'm gonna say the large side is here. I have no idea what the large side is, but 48 will be my small side and x will be my medium side. So I'm gonna put 48 here and x here. And then for my large side, I'm gonna leave it blank. All right, from the red triangle, I'm gonna use 36 and 48. From the blue triangle, I'm gonna say 36 goes with 48 from the blue triangle, and then 48 goes with X. I'm using corresponding sides. I used red and blue so you know where I got those measurements from which triangle I got them from. Now I'm just gonna cross multiply. 36 times X gives me 36X. 48 times 48 gives me 2,304. And then let me divide both sides by 36. And X is equal to 64. That was it.